Hi students, in this video I will be going through question B1. Let's take a look at the question now. Figure B1.1 over here shows an irregular shaped object being placed into apparatus X. Now if we look at the figure, right, we see apparatus X. In apparatus X we see that there is some liquid, okay, and then there is this irregular shaped object being placed into it while it's being suspended by a string, okay. And this is held up by a tripod stand over here, and there is obviously some sort of measuring apparatus next to it labeled Y. Part 1 requires you to state the names of the apparatus labeled X and Y. Now let's highlight state the names. State the names tells us that we need to identify what these apparatus are called. Okay, so some of you would have already noticed by now that this is a classic displacement can setup. Okay, when we want to measure the volume of an object, of an irregular shaped object, but perhaps it's too small to be directly put into the measuring cylinder, we can use this displacement can method. Okay, so X is a displacement can. Note the spelling. D-I-S-P-L-A-C-E-M-E-N-T, can, okay, and Y is our measuring cylinder. Okay, so how this works is, it works through the displacement method. When we put in the irregular object into the water, okay, what happens is that the volume of water that is displaced by the object will flow out and into the measuring cylinder, okay? And how we can find out the volume of the object is by reading the measuring cylinder reading over here. Okay, the volume of water in the measuring cylinder which has been displaced by the object. That is our next step. The student looks closely at apparatus Y, as shown in this figure below. He records the volume of the irregular object as 6.8 cm cube. Okay, state the error that was made by the student in figure B1.2. Now we see something wrong, okay, with this eye level. Okay, it is not straight at the level of the water. Okay, it's not looking straight at the level of the water at eye level. Instead, he is performing what is known as a parallax error. Okay, and actually this question B1A part 2 is asking you to just tell me what error this is. Okay, state the error, so the error is a parallax error. Correct volume of the object requires you to use your skills in reading the measuring cylinder reading. Okay, so we'll read at the bottom of the meniscus over here. So it should be 6.1234566.6 centimeter cube is your answer for part 3. Let's take a look at the next part. The student discovers that the object is a piece of quartz with the density of 2.66 gram per cm cube. Do take note, okay, that this is still a continuation of B1. So the object mentioned over here is actually the same object that has been seen ever since figure B1.1 over here. This is the piece of quartz, okay? And the volume of the piece of quartz, now that we know it's quartz, you can write down quartz, alright, is 6.6. Why am I raising this? Because you will need the volume in order to calculate one of your calculation questions below. Okay, so now let's return to part B. He discovers the density of the quartz, and he then decides to drop it into a beaker containing 3 liquids, a mixture of 3 liquids, water, petrol, and mercury. The densities of the 3 liquids are given to you in the table below. Okay, so density, you would recall, it has to do with floating or sinking. The more dense the liquid is, alright, or the more dense an object is, it will sink whereas the least dense, in this case petrol 0.75, will float. Okay, so it's the least dense, okay, float. So this is the top layer. The one that sinks is the bottom layer, and water should be our middle layer because the density is in between petrol and mercury. Now in the diagram of the beaker below, draw an oval to indicate the position of the piece of quartz after it's dropped into the beaker with 3 liquids. Let's highlight the density of our quartz, which is 2.66 grams per cm cube. Okay, it might help if you pencil in the different densities over here. Okay, so if you write down that this is this layer here is 13.55, this is 1.00, this is 0.75, okay, from the bottom to the top. All right, thus our quartz, which is 2.66, should be able to sink down past our petrol, down into our water layer, but it is not dense enough to sink all the way to the bottom. Okay, so I accept actually 2 different answers. As long as your answer is between, alright, the bottom half of our water, which means that if you drew it like this, I will give you the mark. Or if you drew it like this, I will give you the mark. Okay, so either right at the bottom of the water layer or right at the top of the mercury layer. Okay, this is where the piece of quartz will be. Now, for part 2, calculate the mass of the piece of quartz. You will need to recall your density triangle again, because we are given density, we are given volume, we do not have our mass. Okay, so density equals the mass over volume. You will need to manipulate this such that we see mass equals to density times volume. We have density from the instructions here in part B, 2.66, let's write it down. And we have the volume from A part 3, 6.6 cm cube. So 6.6. Therefore, when we use our calculator to find out what is 2.66 times 6.6, you should be able to get this answer, alright, with many decimal places. And remember that all non-exact answers need to be in 3SF. So if we express this 17.556 in 3SF, it is 17.6, and do not forget the unit, which is grams. Okay, so the correct answer should be in 3SF 17.6 grams. And this is your answer for B1 part B, second part.